Hello dear students of plus one medical, non-medical and respected teachers. So today I am going to discuss the topic work and power and their units in SI and CGS system from the chapter of work, power and energy for plus one class. So first of all, what is work done? Work is said to be done when a force acting upon the body displaces it through a certain distance. If there is no displacement, there is no work done. And mathematically, work done is equal to the product of force and displacement, dot product of force and displacement. So suppose this is a body, F is a force acting, making a theta with the direction of displacement. So it displaces the body through certain distance s. Then this force can be resolved components F cos theta and F sin theta. F sin theta balances the weight of the body. F cos theta is responsible for the displacement of the body. So it means work done is equal to force into distance. So F cos theta into S or Fs cos theta or F dot S. So work done by a body is equal to the dot product of force and displacement of the body. Work done is a scalar quantity. Now, first of all, when theta is equal to 0 degree, that is force acts in the same direction as that of displacement. Cos 0 is equal to 1, then W is equal to Fs. Work done simply is equal to product of force and displacement, and it is said to be positive. For example, a horse pulling a cart, engine pulling a train. So in this case, work done is positive. When a body is falling freely under the effect of gravity, work done by the gravity or gravitational force is positive. Now, when theta is equal to 90 degree, work done is 0 because cos 90 is 0. An example, for example, a coolie taking some load on his head and moving from one place to another place with uniform velocity does no work, because in this case force which is acting vertically upward, he is applying force to lift the load in the vertical upward direction, but he is moving in the horizontal direction. So work done is 0 because angle between F and S become 90 degree. So cos 90 is 0. But if he is moving with uniform velocity, if he is being accelerated, then there will be some work done. So when theta is equal to 180 degree, Fw is equal to minus Fs. So work done is said to be negative because cos 180 is minus 1. So work done by friction is always negative because friction is always opposite to the displacement. Work done when body is being lifted against gravity. So work done by gravity when body is being lifted up is negative. When S is equal to 0, W is equal to 0. When there is no displacement, there is no work done. For example, a coolie taking some load on his head and standing at a place for 1 hour, 2 hours, say, does no work. But in daily life, he is paid something. Coolie is paid something. Even physical work done is 0. So it means physical work done and daily life work done are different. A teacher teaching in a class does no physical work because he is not doing any displacement. A gatekeeper doing his duty on the gate does not do any work because net displacement is 0. So this is all about the various types of work done and examples. Now geometrically in plot graph between F and S, if force is constant, graph comes out to straight line with x-axis, and if force is variable, graph will be like this. When force is constant, so work done will be area of the this rectangle, force into distance, that is work done is equal to area under Fs graph, the straight line AB, area under straight line AB, that is W is equal to Fs, or area OABSC, OABC, OABC. total area under straight line AB gives the work done. When force is variable, suppose small strip ABCD having thickness ds, then suppose F is the force which is constant for this small displacement, so F into ds is the small amount of work done, or F dot ds is equal to small amount of work done due to small displacement ds. So which is nothing but area of the strip ABCD, and this whole area of the graph can be supposed to be made up of a large number of such strips. If in total work done is added, total area is added, the total work done will be equal to integral 0 to s F dot ds is equal to area, total area under Fs graph. So geometrically, work done is equal to total area under Fs graph. Now units of work. Number one, S absolute units. In SI system, when F is equal to 1 Newton, S is equal to 1 meter, W is equal to 1 joule. So joule is the SI unit of work done. So work is said to be 1 joule when a force of 1 Newton displaces the body through a displacement of 1 meter in its own direction. Similarly, in CJ system, when F is 1 dyne, S is 1 centimeter, W is equal to 1 erg. Work is said to be 1 erg when a force of 1 dyne displaces the body through a displacement of 1 centimeter in its own direction. 1 joule is equal to 10 raised to 7 ergs. Number 2, there are gravitational units. Now, in SI system, gravitational unit of force is 1 kg force or 1 kg weight. S is 1 meter, therefore W is equal to 1 kg meter. So kg meter is the gravitational unit of work done. In CJ system, if F is 1 gram force or 1 gram weight, S is equal to 1 centimeter, then W is equal to 1 gram centimeter. So 1 gram centimeter is the CJS unit of work done. So this is the units of work done in SI and CJ system. Then we define power. Power is defined as the rate of doing work, or P is equal to W upon T. W is equal to F dot S upon T. So S upon T is nothing but V. So it means power is defined as the rate of doing work, and it is equal to the dot product of force and velocity. As work done is the dot product of force and displacement. So units of power in SI system, when work done is equal to 1 joule, T is equal to 1 second, or when force is equal to 1 Newton and velocity is 1 meter per second, then power is said to be 1 joule per second, that is 1 watt. So watt is the SI unit of power. So power of an agent or a machine is said to be 1 watt if 1 joule of work is done in 1 second. In CJ system, if W is equal to 1 erg, T is equal to 1 second, power is equal to 1 erg per second. There is practical unit of, some bigger unit of power known as kilowatt. 1 kilowatt is equal to 1000 watt. And there is one more unit known as horsepower, which is defined as the average power of a horse. And this average power of a horse, that is 1 horsepower, is equal to 746 watt. Some engine, some like tractor are given in the form of horsepower. So horsepower is the practical unit for machinery. So this is all about work and power and their units. In the next video, I will discuss energy, types of energy, and expression for energy. Till then, stay tuned for next video. Be happy. All the best. Good luck.